Today I'm going to start with a brief introduction to students' t-distribution. Now, I've already talked about calculating different things with z-scores. When performing any type of test or analysis using a z-score, it's required that we already know what the population standard deviation is. But in real life, that's hard to do. It is always almost impossible for us to know the population standard deviation from which our sample has been drawn. So the question is, how do we perform an analysis if we don't know what the population standard deviation is? And in this case, we use students' t-distribution. Now, below here I have the equation for a z. You can see that it uses the population standard deviation. And next to it I have the equation for a t, which uses the sample standard deviation. As you can see, these two equations are almost identical except for the different standard deviations. The major difference comes from degrees of freedom. And you may have heard me talk about degrees of freedom already when I was talking about calculating sample variance and sample standard deviation. Students' t-distribution has n-1 degrees of freedom. Remember that we're no longer being given the population standard deviation. Instead, we're trying to estimate it with the sample standard deviation. That means sample standard deviation itself is a random variable that we're calculating. So I'm talking about degrees of freedom, and the real deep explanation, the actual proof for degrees of freedom is far beyond the scope of an introductory course. Just try to understand that by calculating sample standard deviation, we're giving it a fixed value. So that is one value that is no longer free to vary. Now, these degrees of freedom change how the probability distribution looks. The probability distribution of t has more dispersion, basically a larger variance or standard deviation, than the normal probability distribution associated with z. When performing tests using t, we expect the probability distribution to look slightly different. So because of this, we're going to use a different table to calculate the areas associated with different areas of the graph by taking degrees of freedom into account. So you may have seen me use this z-table before. It just tells us what areas are in the different areas of the probability distribution for a normal curve. Instead of doing, complicated calculus, we just have this table of values so we don't have to do that. But now we have a t-table which takes into account the degrees of freedom, which I have here marked in red. You can see a bunch of different things here, like critical values, one-tailed, two-tailed, degrees of freedom. We're not going to talk about that yet. I'm actually going to talk about that in the next lecture. But just realize that we're going to be using a different table because now we have to take into account how these degrees of freedom change how the distribution looks. And that is students' t distribution.